Cool. Well, hello everyone. Welcome to Memgraph's community call. It's for those that are paying attention. It's actually the second one this week. On Tuesday, we had one of our partners called Graph Build do basically a webinar, community call on how to build a massive, gigantic knowledge graph from the public data set of Amazon reviews. And then how do they actually build it? How do they ingest it into Memgraph, and then ask questions about it for the GraphRag use case? Today, however, I am super pleased, and it's my basically pleasure to share that we've got the amazing guys from Capitec Bank with us, who will be sharing more about how are they actually using graph databases, what are they doing, what are kind of the use cases, how are they in a way geeking out about a bunch of things, kind of with Memgraph in their spare time and obviously professional time. So we've got Derick and Jan, and who will kind of tell the story. But in the preparation for the call, what I basically did, we have been working with Capitec now. It's coming to the second anniversary, but basically the relationship kind of started even earlier when by our kind of systems, what we monitor, we've seen kind of that a bunch of engineers, and Jan in particular, have been roaming around our documentation, trying and playing with the community edition, with the open source version, for a while before actually kind of engaging kind of on the sales side, if I can kind of say it like that. So we are super happy to have them as partners, and really happy for them to participate in this community call and basically tell their story. So guys, the floor is yours.
Thank you, Marco. Yeah, it's a pleasure to be here. And yeah, Jan and I have worked a long time on this, and we're really excited to share the story. This is one of many. So I think let's do the introductions. So firstly, I'm Derick. I work at Capitec, and I'm the head of client data platforms. I long time ago studied electronic engineering, applied math, and computer science, and my Capitec journey has been 8 years, and I've been a system engineer, a solutions arc, and lately a product head. And yes, it's a great company to work for because we get time to actually play with really cool tech to assist our clients to actually bank better. Over to Jan.
Hi everyone, it's Jan here, and it's nice to meet everybody. Yeah, I started with statistics and specializing in data science. Mathematics is always fun, as well as solving some interesting problems. That's how we got to Memgraph and graphs itself. But yeah, I started here as an intern at Capitec, and then after that, data engineering. That's where I started with my role with Memgraph and building graphs, and then those expertise helped me a lot when I moved into more the role that I studied for is the data science role. And yeah, this is it's going to be an interesting conversation talking about the data engineering, data science parts that we used.
So good news for everyone that loves a piece of data science. Jan really geeks out about that. So there's a lot of data science later. So if he goes down rabbit holes too far, I will stop him. But he really loves it. So if you have questions later, please ask them. So firstly, about Capitec, we are a digitally led bank in South Africa, and we actually use data and technology to deliver simple, affordable banking to millions of personal and business clients in South Africa. The company was founded in March in 2001. Currently, we're South Africa's largest retail bank with 25 million customers that are active. We're also the leading digital bank with 14 million active app users. We also have a physical footprint because we believe it's still important in the country where we stay and sometimes over the world to still have that personal contact. with clients for actually more important decisions, right? It's not always so easy to just trust the computer. And that's why we still have branches and business centers and also quite a couple of ATMs. In South Africa, cash is still king, and we are still trying to convert a lot to digital. But actually being able to service the client throughout where they want to be helped is one of our key things. Data and technology is really important to us, and we are built on that. And we deliver simple, affordable, and transparent solutions. So we will take on the complexity so that the client doesn't have to see the complexity. And we personalize our services at scale. What our purpose is actually to make a meaningful difference in our clients' lives, right? So we really are client focused, and we do what we can to actually not pass on any cost to our clients and actually make it as affordable as possible to bank with us. And we want to unlock growth for our individual customers and our businesses that we have. Then, firstly, I think the best place to start for a call that is internationally hosted, right, is South Africa. It's quite a nice place, and it's actually easy to know where it is because it's in the name, right? South Africa. I think sometimes some people struggle with where our country is, but it's right at the bottom. That's our flag, lots of different colors. We actually have 12 official languages, which make things very interesting, and understanding people is really interesting here, and a lot of people speak 3 or more languages. We have quite an interesting setup with our capital. So we have executive, judicial, and a legislative, and they are Pretoria, Bloemfontein, and Cape Town. Our country is also quite big, right? So from Cape Town to Bloemfontein is actually 1,000 kilometers, and Bloemfontein to Pretoria, 450 kilometers. The population currently, as reported by Stats SA, is about 63 million, and they divide it up in different demographics. And then our currency is Rand, R-A-N-D, and currently it's not worth that much, but we are very positive about our country and moving forward. So just comparing actually South Africa and how big it is to countries in Europe, and as you guys can see here, South Africa is quite big. It's larger than most countries in Europe. And then there's quite a lot of huge countries in Africa as well, and US. And so it's an interesting place to stay because there's a lot of room for all of us, and we're not a lot of people. And why you should come and visit us is these guys. We have the big five. So book your safari, come to South Africa, and I promise you, you'll have a good time. So over to our agenda today. Firstly, why do we care about fraud? Next, why did we choose Graph? What was our use case? What is the problem we tried to solve? How did we solve it? And then actually what we recommend to you if you actually want to take on this challenge. So why do we care, right? Firstly, in South Africa, fraud is actually skyrocketing, and according to the Fabric report, it went up 86% in 2024. View of card not present actually going up 26%, right? So that's card payments through websites and so on. And then actually it's quite a big problem for us, right? If you can't trust a bank, it's not ideal. So we really care for our clients, and we need to combat fraud, and we'll do everything to do that. The other interesting problem these days are hackers and scammers, and also these days AI, right? It makes it way easier to actually impersonate and scam clients. And it feels like a mass attack these days on all of us, right? I think one of the biggest things we struggle with is all our parents are a lot of the time scammed, right? And there's no way to stop that. In Capitec, as I said earlier, why we care is we want to protect our clients, we want to protect South Africa. So why graphs? First thing I did is I actually Googled main use cases for graph databases. And I think Marco said Jan was first, but maybe I was first. And I found cybersecurity on their website, and I really love that because we also do cybersecurity in the bank. Energy management systems, that wasn't so interesting, so skip that. Recommendation engines, very nice, so like that. Data lineage, not as sexy a topic, but it's also a good thing that we can solve things with. And then identity and access management popped up, and we liked that. And after that, I found credit card fraud detection, and that one stood out. So Jan actually started to play with this example that Memgraph had on their website, and we scrolled on and we saw network resource optimization. That's not interesting yet, but fraud detection and insurance is also important for us since we also have insurance business, and we were very excited about that. So that's the reason why we got to graphs, and somehow these things ring true and we want to start playing. We are not in the fraud department, but we went on a side quest to figure out how we can help our clients. So our use case we want to talk about today is authorized push payments. So that's basically where you will get scammed by paying a scammer and not receiving what you paid for. So a lot of the examples actually is you buy a MacBook, the MacBook doesn't show up. But guess what? That fraudster actually doesn't just target you. They target quite a lot of clients, right? Or a lot of people. So what that means is if we're going to start talking about graphs, it has a high in degree detection, right? So basically that fraudster, there's a lot of money flowing to his account. And here it shows that it happens quite quickly because they need to actually get paid quickly and then start to actually move the money. So it's an interesting thing to try and detect, and this is a good place for graph. This will not really work in a relational world. Now, how we solved, or how a lot of banks try to do this, is you have this thing called the investigation map. So the fraud specialists, what they do is they look at your transaction history for the different clients, and they actually map it. Alice paid Bob, Bob paid Charlie, David paid Alice, Alice paid Eve, Frank paid Bob, Bob paid Grace, and so forth, right? And as you can see, this takes a lot of time, right? Because if you have a lot of transactions like we do, this is just actually physically impossible to do at a large scale. So the answer is the graph, and it's quite obvious because they actually draw out that investigation map. So it's interesting on one op, but if you look at two ops, that is where you really get more information and you can actually see common fraudsters between clusters. And then if you go to N ops, this is really powerful. And Memgraph does this quite lovely, and being in memory, it is fast and it's really performant. And it's the hidden fraud connections that you can discover here that's very important, right? And if you can find a pattern, you can actually weed out quite a few of the scammers at once, right? So I'm handing over to Jan to tell you how he approached the problem, what we did, what we built, and over to Jan.
Okay, thanks very much, Derick. So what we sort of started doing is saying, okay, now that we have our graphs and we asked, our fraud investigators to maybe play with it a little bit, just to get some feedback and so forth, we said, okay, no, graphs is, we see the return on our investment and so forth on the data science part, or as well as the graph part. So let's invest our time with this. So firstly, we said, okay, let's map out our first traditional approaches, especially in the machine learning approach or data science approach. is firstly, we have two parts. And remember these two parts as the first part is firstly looking at your main source of table or table. And this is normally where you will put all your pre-processing data into one table. And then after that, you go to step 2, where you will generate additional features on this main table. And then with these features, you will then persist it in a feature store of some sort. And normally the table would look like you have at step 3 your the client identifier or any identifier, and then as well any features that you would have of these of this identifier record. As soon as you have this table, normally in data science, they say 80% is data engineering and 20% is data science. So this is well done to you. You've just achieved the 80%. So now that we can lie back and relax, the part 2 comes, and this is where you will use your table and your features that you engineered and use it in your model to train on, and this model will give a score of some sort. Now that we've covered the boarding approach, now we said, okay, how can we make this a bit more interesting? And this is where we started going to graphs. Now this might look interesting here, but bear in mind, this is only 2 additional steps. Now the steps here is exactly the same as the first step, is looking at your main source pre-processing table, then taking that table, transforming it into a node table or an edge table. This node table will sort of look as your client identifier and any client information that you would like to add into your nodes. Then after that, you would have your edge table, where you will then connect those links that is in your node table. Now, as soon as you have this is the hard work sort of, but then you will then import that data into Memgraph itself, which we are very impressed with the import speed with it. And then as soon as we've created the graph, now we could start playing with their graph feature capability, as the algorithms is inside of the database for you. So you don't have to go through sleepless nights thinking that you missed something in the algorithm. After you've done this, you will then persist this in a feature store of some sort again. This will then just have additional graph features. So, for example, page rank, degree centrality, or any community count of some sort. And then as well, now it's pretty much the exact same as the traditional approach. You use your graph features and you train your model in part 2 on those features. Now that you have that, and now that we planned for this, we then said, okay, let's start looking as well at our graph schema that we're going to use for our use case. And what we said is, okay, we're just going to start as simple as possible, because we don't want to make it too complex, especially the first version. And this is where we started with the heterogeneous graph, where you have 2 different, or well, 2 or more different kinds of nodes. So as you can see, firstly in the orange, we had a client node, and this client node had an account, which is then in the blue. What you'll see is this arrow going into itself is that you will see that we also made our lives a bit more interesting, is looking at directed graphs, where you will see there are ingoing and outgoing flows of transactions. So by doing this and creating the graph, what we also learned throughout the process is that by taking a more complex heterogeneous graph and then seeing that you have orange client or orange nodes here, which represents clients, they could have multiple accounts. So meaning that it can make the network or the graph very complex and sometimes very interesting to cipher out. So therefore, we then tried simplifying it to a more homogeneous graph, which is quite optimal for any PageRank algorithms, especially on large data. So we would definitely recommend simplifying your graph as much as possible before starting to run those heavy computational graph algorithms. After we've done this, we then said, okay, obviously we're looking at the fraud use case. And then what you would have is a normal graph here, your original graph. Now, as well as if you have the graph, now it's sometimes very difficult to sort of get ideas of feature engineering. Now, Memgraph and what we love about Memgraph is that you can implement your own logic. And this logic that we implemented was our Y label, which we said, okay, go to the client nodes and then add a fraud status on those nodes and represent it by using Memgraph style in blue and red. And by doing so, you can then start seeing the labeled graph more easily, and then you can start feature engineering interesting features. So for example, by looking at triangles, seeing if triangles are important to your data or graph. So this really helped us a lot to visualize certain things and come up with creative ideas, which we'll share now. This is now where we get to that part. So firstly is that when we had the graph and now we said, okay, let's start creating those features, we said, okay, but what is the objective of those graph features? And the objective what we came to is by summarizing the characteristics of the client's nodes into a single interpretable value. And that single interpretable value is very important, but it also is very dependent on those single connections. Now, by looking at that, we firstly looked at algorithm-based features, which Memgraph provides, which is firstly your PageRank algorithm, degree centrality, any community detection, that kind of algorithm. It's quite fun playing around with all the algorithms and algorithms that keeps getting added. So that was quite fun. And then as well, we said, okay, let's look at more connection behavioral features, meaning that go look at your neighborhood and then start summing up the leaf nodes values into your neighbors and then summing and aggregating it up until into your node. I'll explain more about this shortly, but just to show the algorithm-based feature that we looked at, for example, is your degree centrality. You'll look at, say, degree. So you'll start with the amount of connections. And then what we said is, okay, let's start getting creative. And this is where we start looking at the second kind of feature batch that we engineer, is by looking at more your connection behavioral features and aggregating those things. Now, what we mean with that is that if you look, say, at this original graph here, what you'll see is 2 hops away from that red node, we have feature values inside of the nodes 2 hops away. And what that could represent is the total amount of inflow that someone has, total amount of expenses someone has. It's whatever floats your boat, you can add there. Now, when we had that graph, we said, okay, now add all of these leaf nodes and aggregate it into the 1 hop node. And therefore, you start bringing in your network into a single interpretable value. What you will then see is that every iteration, you will then go down, 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 and then where you will get your final value, where you will add this into your node property. Now, as soon as you've done this, you will then need to understand the following, which is very important and where we also hit some interesting things along the way. Now that you have your features and we engineered it, we said, okay, let's represent it in a tabular format. Now, by taking this graph here, we said, okay, let's say, for example, look at node F, client F. Now, client F in a tabular form will be represented by your features, which is page rank, your degree, any other linear kind of features, and then it's represented with your Y label as well as your Y date. Now, this is your targets, and this Y date is very important and must be tracked in graphs, as we'll get to Y soon. But the main thing that you need to understand is if we look at node F and say on day 1, the graph looks like this. Next day, it gets more connections and and the page rank value might go up. Then thirdly, on the third day, you suddenly see that it is fraudulent. Now, this fraud date must then be represented of when that event occurred. And this is how graph features change every day when you persist it in your feature store. Now, this date that I am talking and hammering on is very important because this is where we come to our next learning lesson. Now, this learning lesson you will read sometimes in papers, but it is a data science worst nightmare. So it is called data leakage. Now, what is data leakage? Is firstly, let's look at an example. Now, we look at a feature here that we, or anybody engineered as well as in certain papers, is that let's look at the number of fraudulent links to a specific node. So what we're going to focus on is this gray node in the middle. And we're going to say, okay, create a property that represents all those number of fraudulent clients that's connected to it. Now, let's start by creating this feature is that, say, we want to now count. So we count, okay, yes, client 1, it is fraudulent. Then you go to client 2, that is fraudulent as well. Client 3 is fraudulent. And then client 4 is not fraudulent. So the total amount that you would get is 3. Now, welcome to your nightmare. Is that you've just introduced data leakage into your whole process. And the reason why is you did not look at the target date of when the event occurred. This is very important. So let's look at actually understanding why. Now let's count again from the start. Now we say, okay, client 1 is fraudulent. That date, the 20th, was before the event that we are interested in. Then we say, okay, we can count that node. Then we get to client 2. Client 2 was found fraudulent on the 22nd, which was after the target date. Now, if you included this into your feature, you would then experience data leakage. Therefore, you would skip this and just go to the next. And we all know node 3 is now fraudulent, and then node 4 is not fraud, which then comes to 2. This is a very common mistake in graphs, and you will sometimes get into it, but luckily by this example, you'll start understanding what could happen. So after we had these features and we made sure that data leakage could not occur, we then had all of our data and features into a table of some sort. Now, as I said, my worst nightmare as a data scientist is data leakage. We even went the extra step of now sorting these Y dates so that we can force every client ID or record to be or abide by a time period in ascending order. Now, if you have this, the next step in a data science process is to then start looking at splitting up your data. And we started splitting up our data into 4 pieces. The traditional approach is to split up your data into 80-20%, 80% of your training data, and then 20% is your test data. And then your out of time is normally your production like testing, where it is very important. What you will then see through doing this and looking at your training set is that in the real world, you'll get some problems with data and the imbalance of it. Now, in fraud specifically, you'll get a very high imbalance of your fraud ratio versus your non-fraud. What this means is if I go and say, okay, each day I go count the number of fraudulent records as well as the non-fraud records, I can then start slowly seeing that there's a large difference between these two different kinds of clients. Now, what you will then start seeing if you plot the non-fraud distribution beside the fraudulent distribution, what you will then see is quite a high imbalance, and the fraudulent records and distribution will start hiding away. This is a very problematic thing in when you want to train your model. The reason why is that your model will sometimes train more on your non-fraudulent records and not train as well on your fraud records. So you might think one day that, I just hit the jackpot. I am going to get a Nobel Prize trophy. But then what you'll see is that it didn't perform as well on the actual things of interest, which is your fraudulent records. Now, after you've experienced this, we then said, okay, how can we prevent or try and solve this? Now, what we did was we said, okay, let's go to undersample our non-fraud clients for each daily graph. What this means is that we would take 100% of our fraudulent clients each day, as well as for each day, we will sample 1% randomly from your daily graph. Now, the whole goal that you have here with sampling in general is that you want your sample to represent your population. And what our population is our daily graph itself. So you'll have, like I showed in the previously, is that you'll have day one's graph, day two's graph, and then day's three graph. Now, each day you will sample certain records, which will use this kind of pattern. But now that we want to sample 1% of our non-fraud clients, what the next question normally is which non-fraud clients what do we want to sample from? Now, this is very interesting as well because we need to abide by our main goal, which is representing our population. And by wanting to do so, we came up with a sampling idea of looking at the distribution of the graph connection patterns. So what this means is we took the non-fraud clients connection patterns and put that into a simple binary vector. And this binary vector represented, the first element is your incoming connections, then your main target non-fraud node, which would be represented by a 0 here in the middle, would always be 0 as it's non-fraud. And then your last element in your vector would represent any outgoing connections. Now, an example of this is we took that binary vector and created these kinds of patterns that we would like to look at. So 4 out of the 8, firstly starting here is your in connection node. So if it's, say, non-fraud connected, then it is a 0. The second element is always a 0 because it's your target non-fraud client. And then if that non-fraud client made an outward transaction to a non-fraud client as well, that would then be represented by a 0. And by changing these elements around your main target node from 0 to 1, you can then start seeing very interesting kind of patterns that you would not necessarily always see. Then what we also experienced is some clients only have inward payments, some clients only have outward payments. And this is where we said, okay, for any of those kind of patterns where, say, your target node only made outward connections or transactions, they are, the incoming element of that vector is represented by a none. And if you go to the right here, you will also see that this target node only had incoming transactions. So by going to your vector, you would then add a none to the last element. Now, by doing so, we took these 8 patterns and we plotted each pattern and the frequency of each daily graph. And by doing so, we got the population distribution. And then what we did is we said, okay, sample 1% randomly, but keep this distribution still in your sample for every day. So by doing that, you have your sampling table now. And by having all your sampling logic that you applied, you then get a final table. Now, this final table then represents your linear, normal, tabular features or your graph features that you just engineered. And this is what we took is that table of taking your features and feeding that to a tree-based classifier model. And what we saw was quite nice. What we then did with our final model is obviously the next steps always is reducing your number of features, but as well as what we looked at and what we see and experience is that by taking your final feature table that we used, we then got to 259 features that we looked at. And with this 259 features, it existed out of 64 features that you can have in your relational database, which is more tabular. But what was really exciting is that we could, by simply using our feature engineering approaches, is engineering 195 new kind of graph features. And we then said, okay, but we want to see if this is valuable. And one way of seeing if this is valuable is saying, okay, run a correlation test. We just want to see, okay, do we actually have new kind of features? And this is where we ran a Pearson and Spearman correlation test just to see if anything has a correlation above 0.7. What we found was it was not. So this was one of our milestones when we feature engineer, is that we engineered new valuable features. And what we then said is, okay, let's go select only 50 features from this feature set. And this is where we got to 23 tabular features and 27 graph features. And by adding those up, we get 50 selected features in the final model. By having this feature, final 50, 23 tabular and 27 graph, we experienced interesting things along the way, especially with the feature engineering. The first main lesson is that if you do start with graph features, it does help improve fraud prevention. But especially in your first version, also use some linear or tabular kind of features, as sometimes your labels, you wouldn't necessarily always have certain labels that represent your graph use cases. So that's why start with tabular features as well, then go and graph, and then slowly but surely start moving to just graph features. Another thing that that was pointed out is that graph features break with SHUP. Now, I'm not going to go into too much depth into SHUP, as I can spend an entire meeting on that, and I don't think you guys want to hear my boring voice for that long. So what will then just come out of this is that we saw that graph features are dependent. A pays to B and B pays to C. All the connectiveness is and creating features is very dependent on the graph topology and network structure. What we then said is, as well, and saw is this breaks the core assumption of SHOP, and the core assumption is that all features should be independent. There are certain approaches where you can use graph SHOP. There's some papers regarding that. We did not go into that, but it was interesting just because we did run into this. Then what we said is, okay, now we do have our model, and we then started mapping out our production infrastructure flow. And this is now where we implemented or used Memgraph, especially. We said, okay, like I mentioned in the or the methodology, is that firstly create your graph, then you need to create and retrieve these graph features, where you will then persist these graph features in a feature store of some sort. We use AWS and other tools, which helps, especially with scalability. Then after that, you'll look at your third glue job here, which is very near to your SageMaker endpoint. Now, your SageMaker endpoint is where your model sits. So this is where we took our production or our model that we were happy with, and then we added that to our data science platform, which is well done to the team there. Amazing and quite fast, and this is where we added the model there. So as soon as you, and this glue job here, you'll get your features, that those features would be then sent to your model endpoint. And then as soon as you get your scores, it will then be inserted in your feature store again. Now, we also use other layers, like the experimentation layer of any feature flags. This helps with A/B testing of seeing if you retrain your model, is it better than the current model? And all those nice things, which the data science platform also helps to provide quite nicely. Then after that, these feature flags would then help identify which records to select. And this is where our last glue job comes in, is to retrieve those published records or needed to be published, and then produce it to a Kafka topic. This would then be in the topic and then be consumed by our case management layer, which is then Salesforce. By having all of these complex steps, what was quite amazing is that our results that we had in the end is that what we saw is we score about 3.5 million plus. That is growing exponentially. And this is the daily amount that we score every day. Now, this and the infrastructure running from start to end is 2 hours on average, and the average is for a month period. Then what we also saw, and what we were really excited about, is that our model was the best syndicate kind of model that we had, and this produced a monthly average false positive rate of 2.1.
I'm just going to stop you there. What does that mean?
So it means that, so for example, you look at a fraud investigator's perspective, you would work through 2 non-fraudulent clients, and then after that, you would find a fraudulent person after those 2 that you've investigated. Ideally, always you would like not to create any friction with clients, so therefore you would try and optimize so that that number is as low as possible. So we found this to work at scale, and then we come to our not a final slide, but our recommended road to success here is that what we would recommend to any Memgraph client, or if you start with graphs, is to do these 5 steps, and this is how you can plan out your project. Is firstly, you start looking at your current data sources. Now, that might be on your relational database, NoSQL, even just files. You would then import that into your graph. Now, by looking at the graph, you'll make some tweaks, and then as well as sometimes you want to reduce that complexity, or even add certain links that would help with the time complexity. So therefore, this will then, your graph would then change and until you're happy with it, as well as normally, you're happy when it solves the objective that you have of the project. But as soon as you're there and you think you have the graph, you would then need to importantly provide that to a subject matter expert. So for example, with fraud, give that to a fraud investigator. The feedback helps quite a lot because there are certain things that you won't necessarily see or make assumptions, and those assumptions can be wrong. So you don't want to make those assumptions, especially later in your project. Now, if you have done this and the SME is happy with using the graph, well done, you've achieved your first milestone. Now, after that, you would then start looking more at identifying common patterns with the help of Memgraph Lab, which is really nice, especially the visual aspect of Memgraph. And there you can start exploring new kinds of patterns that you haven't seen before, or even patterns that you have seen before, but you want to automate this process. So by doing that, you would run a Memgraph Cipher query, and then you would generate some reports, which was then sent to or the SME or any business stakeholder. Now, if everybody's happy, your second milestone is achieved. This is quite a great achievement, but we want to even be more more complex, well, not complex, but we want to expand our horizons. Is by looking at the fifth point this is where we started looking at create your graph features. Now, what I mentioned as well is by looking and using Memgraph's visualization tool in Memgraph Lab, you can then start exploring interesting patterns, which you can then use to create new graph features. And all those nice things. You could also, what we found is with feature importance. Feature importance is it could be as simple as, do you understand this feature by looking at the graph structure? If that's a yes, it could be a really important feature for business if it needs to be interpretable. And then after you've created this, your graph features, and you've persisted that in the offline or online feature store, you would then start using these features and train machine learning models on these. Now, if you've gotten to this is your fourth milestone. This is where we are, and still looking at even making this more interesting.
Is that your final milestone, or do you have bigger dreams, Jan?
I have bigger dreams, but we'll not speak about that here.
Good. Okay, thank you, Jan, for taking us through the in-depth views here. Just want to start wrapping up before you get to questions. Is for the great work Jan and Johan did. Is actually we won the 2024 Think Big and Innovation Award in the bank. And the great thing was we're not the fraud team, right? We just wanted to help and actually use great technology to solve the problem. So Jan and Johan here from left, they're the data scientists. They did all the graph work, the figuring out, and as you guys can see, there was a lot done. Francois was the head of data platforms at that time, and he left us to experiment. He always asked, what is Jan up to? And I said, he's doing great work. And he said, when it's going to be ready? And I said, when it is ready. And I believed in graphs a long time ago and really wanted to play with it. And it helped that we were able to play with it. And our CIO, Wim de Bruin, on your right there, he saw the potential and he backed us all the way. So that's always great if you want to play with new things in a larger organization, get the executive buy-in right. Then 2 or 3 other people to mention that weren't present in this photo, right, is Andrew Baker, our then Chief Technology Officer. He's such a big fan of graphs. He built his own one on his Mac and played and put blog posts everywhere. So if you get people that excited, there must be something. And then the guys that really actually helped a lot, right? That so that this could run, Charles Muller, our platform engineer, and Francois Ferreira, our machine learning engineer. They built the infrastructure that Jan actually put together and actually got working as a prototype, and they actually got it working with AWS. Then one thing I just want to talk about is graphs are worth it, but you need to invest the time. It's so different to how normal databases work, right? It's not a pick it up and just go thing. So in 2022, we started experimenting with it. We built some data lineage tracking things. We tried to figure out who are the bank's most important providers of services by looking at the linkages between them and the departments they worked for. So that's a procurement thing. We did quite a lot of other interesting things for merchants, and we just played with it to actually learn it because Cypher is different. It's good, but it's the thinking and pattern matching is not as easy with as you might think. And then in Feb 2024, we actually partnered with Memgraph. And the good thing is, quickly thereafter in April, we were live with our first graph. And I think the open source nature actually really makes this possible, right? Because we could play with this for literally for free and actually get it production ready and actually deploy. And the good thing is now in 2026, right, we have 7 graphs live. And guess what? Jan only built 2 of them. So the good thing is we got other teams to build them. We are no longer the bottleneck. And it's really good to actually see how people start to think differently about connected data and what it could mean in a bank that actually has highly connected data. If anyone has any questions, now's the time. Jan would really love it to geek out on a lot of data science questions. So, yeah, please let us know if you have anything.
Cool. Well, thank you, Jan. Thank you, Derick, for the presentation. Anyone has any questions? There were kind of at some point, I think, 40 people live listening, so definitely a lot of attention. I cannot really see any questions.
That's either good news or very bad news. So let's say it's good news because Jan explained it very well.
That is true. Cool. Well, we can, I think, leave it maybe for now. Presentation left everyone speechless. That's what they say. Amazing. Well, listen. Thank you, guys, for the great presentation and sharing your experience. And especially what I really liked was how you took everyone from on your journey from basically getting onto the bandwagon and now actually having a full train. So that was really kind of inspiring and really good to hear. So thank you so much. If there's anything kind of that people want to kind of hear more, definitely drop us kind of a line, drop us a note, and we will see all of you definitely very soon. Thank you guys once again.
Before you leave, all right, when are you coming to South Africa? Just while we have so many people that are on the call.
We need to arrange, but we need to make a trip. We definitely need to make a trip. For basically for next winter, basically, then like probably like November, December is probably the best time to go, right? So, yeah.
Thank you, Marco. Thank you, everyone. It was fun to prepare this, and yeah, see you soon. We have lots to talk about and maybe share in future.
Thank you. Have a good one.
Thank you, Marco.